Hello everyone, welcome back to the series on programming robot mechanics. In this video, we are going to complete the tests and the documentation. And not the documentation that we wrote along with the code, but the documentation including the README, some examples, and so on and so forth. All right, now this video is going to contain a lot of fast forwards, I think, but we'll at the end, we'll see what we get. Okay, so this is the final README that we have at the outside of the complete project. Oh, let it go. Okay, here one, this one. Like we have the complete GitHub repository that we have, and we have the different parts of the code which we coded in each video. And what we are going to do, for first thing that I'm thinking we should do, we are going to rename all these parts in accordance with the video name that we have. That way it will be easier to maintain and will also look good to the user that we have. Then we will edit this README. That let's just first do that and then let's see what other tasks that we get. So let's do this. Okay, so these are down defined, and now let's fill in the common README of the complete project. In this, we are going to add links to the original folders, and yeah, that's what I'm going to do. So let's do this. Okay, while coding, I also noticed that the part 8 of the videos is not actually included in the playlist of the programming robot mechanics. So I'm just going to do that and then we will resume doing this as well. Okay, so we are done with the README of the overall project that we're going to have. Now, one cool thing that Visual Studio provides us is we have written this markdown file, but we can also view how the file is actually going to look on GitHub. So let's do that. Now I'm on my keyboard, I'm going to press Control Shift. Oh, I think V. Yeah, Control Shift V. And this is going to give us a preview of how the file is actually going to look. It's loading up. Okay. So the final file is going to look something like this, like a component code for each video, for the video series, programming robot mechanics, video and code, and so on and so forth. And we're going to keep extending it as we go along the course, video series. Right. Okay, these are done. Now let's work on the individual README that we are going to have in our main library part, like over here. So let's add some of it now. Okay, so first of all, we have this Python library for robot kinematics, dynamics, motion planning, and control. But we're also going to add some more description to it. This is going to be, yeah, now we are going to add the prerequisites. Prerequisites are something like what the library has been tested on, has been developed on, and how it can be used, like the overall figure. Here I'm going to write the, let's just write it and let's see. Okay. Now here we write what the actual development was done on. It was done on a Windows 10 machine with Python 3.8.8. So that was what it was done on. And we can also write something like the library can be run on any environment as such. Now, this is the case because we are using libraries that are overall available for all platforms that run Python. So that's why we can write that. Otherwise, we would have to include like different installation settings for different operating systems and so on. Now we're going to add this installation. Installation is pretty simple. We're just going to add the pip install one and the Python. Yeah, simply the pip install one, nothing more than that. Here we're going to add the instructions for the virtual environment as well. So for a user, if he or she installs the library that we have or the repo, then he can simply set up a virtual environment and pip install the required dependencies and so on. So let's just add both of these instructions side by side. So yeah, let's do that. Okay, here we have this. Now the next section that we're going to edit is the examples. Now we have provided the code to the complete library, like the people can come and use the library in whatever way they want. But the most important thing is while developing any sort of code or anything, any software, the most important thing, even more than the code, is I believe that the README and the documentation should be really, really much developed. If the README or the documentation is not very well developed, the people are not going to use that library. They won't even get the first stage onto how to use that library and how what are the functions that it provides. So documentation forms a very important part of writing any software that we can have. So what we are doing in this video, we are writing the documentation. Now adding examples is a really good way to let people know how to use the library. So now let's add some examples and let's do this. Now over the previous videos, we had developed some main.py files and some testing files. We are simply going to copy the code from there and add some comments to this and put them in a new folder like examples folder, and we are going to name them accordingly. So that's what we're going to do. So let's do that now. So first we add the examples folder, and now I'm going to copy most of the main.py files and rename them accordingly. And then we are going to add all these examples in the README file. So people can, when they see the README, they can directly browse through the examples for what they want to work on. So let's do that. All right, so we are done with the examples as well. I have included particularly two examples, which are based on the robot and the transformation. Now, why I have not, okay, one thing, I'll just add them in and under the if condition, so it looks a little nicer. Okay, all right. We are done with the examples. We have provided two examples, two instances of examples, like the working with the transformation matrices and working with the robot. Okay, Jacobian, robot and visualization. Okay, so this way we provide the examples to work with both of them. Now, why we have not provided the examples to work with the optimizers? Because our library is based on the robot itself. Our library is made to focus on the development of the robot and not the development of optimizers. So optimizers are basically more of a what we can say developer point of view. It's more important, but for a user point of view, it's not really that important. For the developer, we have provided the optimizers documentation in the function itself. So that is taken care of for the developer. But for a new user that just wants to make use of the library, all the documentation should be present in the README, like for itself. That way, the user that just wants to use the code and not get into how everything is working can just read this README and get on working with it. So that's why we did not provide for the optimizers part. Okay, now we are going to add for the tests. Now I'm just going to add a simple link, simple code example as to how the test should be run and what the tests do, something like that. But the main change that we are going to do is just change the tests, which we have decided to do long time back, but we did not do it. So in this the next section, we are going to work on the tests and improve them to make them more general and better. So let's do that. Okay, so we have added all the changes to the test robot. Now let's see if there are any more changes that we can apply anywhere else. Now we can apply the change over here as well, because the roll pitch yaw angles are, all of them are equal. So let's change them so they are not, all of them are not equal to each other, like something like this. Let's change this as well. All right, so I think we are done with all the test changes that we wanted to make. Now we'll finally run the test.py and see if everything is working fine or not. So let's do that. So we seem to have some errors in RPY to TR. Let's see what these errors are and let's debug them. The problem was with our side only. What we were doing, actually what MATLAB does, in order to compute this Euler to transform, that MATLAB function that we have, the yaw angles comes before, like here the calculation takes place something like this: yaw, pitch and roll. But in our function, the calculation takes place something like roll, pitch and yaw. So order of these values is actually important. That's why we were getting the wrong matrix. So now the order is correct. That's why it's returning the correct matrix. So we're going to now make the changes now. All right, let's run this test again. So all the tests are running fine even after changing. So I think this pretty much means that all the code that we have written is almost error free. That is good to know. Okay, I think we have done what we wanted to do in this video pretty much. Yeah, right. Okay, so in the next video, we are going to start working with the dynamics of the robot. The first thing that we are going to do is we are going to be working with, I think, torques and forces, how they affect the robot and how the joint values and so on, and how the joint torques come out as well. So yeah, let's see what we get in the next video. See you in the next video then. Bye.